All right, folks. Here is here we go. Going to look over 4.2a in Hawks. Do some homework problems from that, and we're just going to dive right in. And so we'll start with number 1, and the problem is of the function f of x equals 7 minus 7/5 x. And so what's going to happen is this particular section deals with a lot of parabolas. However, every once in a while, they're going to toss a function in that's just a linear function. Notice that this x is not squared. And so what I want to do is I want to rewrite this in slope-intercept form. And so I'm going to have f of x equals negative 7/5 x plus 7. And things that we used to know when we had y equals whatever, those still apply. And so I know that the slope of this guy is negative 7/5. And I know that the y-intercept is 0, 7. And so if I had to graph this, which you will have to do in Hawks, and of course you'll have a graph, so it'll be a little bit easier for you. So what's going to happen is I'll graph my intercept 0, 7. So start at 0, 0, go up 7. 1, 2, 3, 4, 5, 6, 7. Okay. And then since my slope is negative 7/5, I'm going to go down 7, right 5. So I've gone down 7, right 5. 1, 2, 3, 4, 5. And then my graph is going to look like this. And so this is probably the only one. I think that you're only going to see one in here that's not an actual parabola. I don't know, there might be a couple, but that's how you're going to do that, okay? And so there's number 1. Now, when we look at number 2, we're still dealing with some linear equations, but it's not asking me to graph this. So here's the information that it's going to give me. It's going to tell me f of negative 4 equals negative 4, and it's going to say the slope of the function f is negative 3/2. And what it wants me to do is it wants me to give a function f of x in slope-intercept form, so mx plus b. My goal is to find something that looks like this and to circle it. And so here's everything that I know. And so what I'm going to do is I'm going to go through and I'm going to label everything that I do know. Well, typically when I say f of x, there's usually an x right here. Well, since there happens to be a negative 4, I know that that's an x value. And I know that when I take an x value and I plug it into a function and I evaluate and something pops back out to me, in this case a negative 4 is popped back out to me, I know that this is a y value. We also know from previous problems in previous sections that when we talk about slope, that's the letter m. And so I have a lot of stuff. I have a y value, an x value, and an m value. Now, a couple weeks ago, before we knew about function notation, we knew that this was really y equals mx plus b. Well, we have a y, we have an m, we have an x. What we do not have is a b. So we're going to take the numbers and things that they give us over here, plug them into this equation, solve for b, then we will be able to go back and actually write the function, which is my end goal. So here's what I'll do. Instead of me writing y, I'm going to write the y value, which is a negative 4, equal sign. Instead of me writing the letter m, I'm going to write negative 3/2 because I know that's the m value, that's the slope. Instead of me writing this x value, I'm going to put times negative 4. Plus sign. B is what I don't know, so I'm going to write it. I'm making it as a capital B so that you don't think it's a 6. And so here I have this equation. I'm going to solve for B. I can do that pretty easily. Negative 4 is going to stay the same. I'm going to multiply these two together. I'm going to do that in my calculator just to show you because I know it's been a while since we've had to use these. So you're going to type parenthesis negative 3 divided by 2 close parentheses. There's my fraction, negative 3 times negative 4. You're going to hit enter. You're going to get the number positive 6. And so you will say, well, this is just 6. That plus b hasn't changed. In order for me to get this b alone, I'm going to subtract 6. And so that's going to give me negative 10 equals big B, which is good. And so now I'm going to take the fact that b is equal to negative 10. I'm going to take the fact that I have the slope, and I'm going to actually write my function. And so when you're doing this in Hawks, here's what you're going to have to have. Here's your function. You're going to say f of x equals, you know that your m value is negative 3/2. X is going to stay the same. Minus 10. Here's my function. That's it. I'm done. All right, we're going to do one more like this just to make sure that you have a good idea of really what's happening. And so number 3, the same thing. We're going to get f of negative 4 is going to equal negative 11. And we're going to find out that the slope of f is equal to the number negative 8. And again, our end goal is to have a function in slope-intercept form. And so the first thing I'm going to do is I'm going to say, well, this is my x value, this is my y value, this is my m value. I know that I need to find slope-intercept form. I know that I need to find a b value, just like I did in the previous problem. And so let's do that. And so what's going to happen is we're going to say, all right, well, instead of me writing y, I'm going to put -4. Instead of me writing my m value, I'm going to put -8 times, instead of me writing x, I'm going to put -4, and then I'm going to put plus b. And so -4 won't change. I multiply these together. That gives me a positive 32 plus b. Hold on, I've made a mistake. I got to go back. I'm looking at the wrong one. Sorry. This should be a -11. I apologize. So let me rewrite this because this is messy. I have -11 equals 32 plus b. All right, now in order for me to get this b alone, I'm going to have to subtract 32. And so that's going to give me -43 equals b. Okay, if it's a weird number, it doesn't matter. This is just to prove a point. Can you do it? And so then over here, for my answer, I'm going to put f of x equals, and my slope that they gave me was a -8. So I'll have -8. X stays x and goes right beside the slope. And then I'll have -43. And this guy right here is my function. This is what you will type into Hawks. And we are completely done with this problem. All right, number 4 and number 5, the ones that we're going to do next, these are going to give us functions that are in vertex form, and we're going to be able to graph these pretty easily. And so the first one is going to be f of x equals, parenthesis, x minus 1, quantity squared, plus 4. And so from our vertex formula, from the notes and stuff, we know that when we're looking at this and it's already in vertex form, I'm going to pull out the opposite of this number. This number is going to stay the same, and that's going to be my vertex. So I know hidden in here is h and k. And so step number 1 that they're going to ask you for in Hawks is, without doing any work, what's the vertex? And so I'm going to look at this and say, well, this looks like a -1. Remember, what we're really doing is we're just taking the number itself. And so I'm going to have my x value is 1, this guy's face value 4. There's my vertex, done. Now, the next thing that we're going to have to do, so step number 2, is we're going to have to find how many x-intercepts there are. And if there are some, we want to actually evaluate them so that we can graph them. And so what's going to happen is I'm going to take the problem that I'm given, and I'm going to have x minus 1, quantity squared, plus 4. And I'm going to set this thing equal to 0, and I'm going to try to solve for x. And so way back when we did these types of problems, what we did was we know that we have to FOIL this out. So I have x minus 1 times x minus 1 plus 4 equals 0. And so I get the FOILing. That's going to give me x minus another x plus 1 plus 4 equals 0. And so I'm going to get x squared minus 2x plus 5 equals 0. And so now what I'm going to try to do is I'm going to try to factor this thing. And hopefully it factors, because if it does, then I'll have 2 nice neat x-intercepts. But if it doesn't factor, then I'm not going to have any x-intercepts. And so typically what I would do is I would ask myself, I need 2 numbers that are going to multiply together to give me 5, while adding to give me -2. So I list the factors of 5, well, it's just 1 and 5. There's no way that I can take the number 1 and the number 5 and somehow make it a -2. And so what's going to happen is I'm going to say there's no x-intercepts here. Okay, so step number 3, then in order for me to graph this, I'm going to need 2 other points so that I can actually graph it. I can't graph it with just 1. There's no x-intercepts, so that doesn't help me. And so now I'm going to need to find 2 other points. Well, here's a hint. Here's a tip. Look back up at your vertex. In this case, it's the x value is 1. Why don't you pick 2 x values that are really close to 1? So maybe we'll pick 0. Maybe we'll pick 2. And so what I'm going to do in order for me to find 2 other points is I'm going to say, well, if x equals 2, then what? Well, then I'm going to take that 2 and I'm going to put it right here, and I'm going to evaluate, and I'm going to get a y value. So I would say, well, f of 2 is going to equal 2 minus 1 squared plus 4. And then inside these parentheses, 2 minus 1 is just 1. That's still squared. I'm still adding 4. 1 squared is just 1. 1 plus 4 is 5. So if x is 2, the point that I get is 2, 5. There's a second point on my graph. Well, what if, let's stay over here, what if x was equal to 0, right? Because we want to stay close to the vertex, so why not 0? So then I'm going to find f of 0, and that's going to be 0 minus 1 squared plus 4. On the inside of my parentheses, 0 minus 1 is -1. I got to square it and add 4. Well, I know that -1 squared is +1, and 1 plus 4 is, again, 5. So if x is 0, I have the point 0, 5. And so here are 2 other points. And so what I can do next, in Hawks, they're going to ask you to graph it. Let's see, 1, 2, 3, 4, 5. This is my downfall. I have a really hard time drawing graphs sometimes. Okay, so I'm going to graph the vertex of 1, 4. So I'm going to go over, start at the origin, and I'm going to go over 1 and up 4. And so here's my vertex. And I have got these 2 points that I'm also going to graph, so I know kind of what it looks like, the 0.25. Oh, sorry, you can't see the graph. I'm sorry. Here's the origin. I've gone over 1 and I've gone up 4. That's my vertex. I need to graph these 2 points so that my parabola can take shape. So I want to graph the 0.25. So I'm going to start at the origin, go right 2, go up 5. So there's that guy. And then I need to graph the 0.05, which also happens to be the y-intercept. So I'm going to start at the origin. I'm not going left to right, and I'm going up 5. And so even though this doesn't look super great because I don't have any x-intercepts, I know that my parabola, oh my goodness, I missed that point. My parabola is going to look something like this. So when you're in Hawks, what's going to happen is they're going to give you a parabola already, and you're going to point and click to the vertex, and you're going to move the vertex around. As you move the vertex around, the points will move around as well. You can fix all of that. So here's my answer. So I was given something that was already in vertex form. I found the vertex. I tried to find some x-intercepts. Turns out there weren't any. I found 2 other points so that I could graph this. I actually did graph it, and now I'm done. All right, let's do a similar one to that one, except for this time I'm telling you we're going to have x-intercepts because I want you to see what that looks like. So the problem is f of x equals x minus 5 quantity squared minus 4. And so, of course, step number 1 is the vertex. And luckily for me, it's already in vertex form. And so when I look at this without having to do any work, I know the vertex is going to be 5, negative 4. So that was easy peasy. Now, step number 2 is going to be my x-intercepts. And so what I'm going to do is I'm going to say, all right, well, x minus 5, whole thing squared, minus 4. I'm going to set it equal to 0. And then I am going to solve for the x-intercepts. And so I'm going to FOIL this out. X minus 5 times x minus 5. My minus 4 is still there, is equal to 0. So here I go. So x squared minus 5x minus 5x plus 25 minus 4 is 0. I'm going to combine my like terms. So I get x squared minus 10x plus 21 equals 0. Now I have to dig deep, and I have to, our favorite F word, I have to factor. And so I set my parentheses open here, and I say, okay, I need 2 numbers that are going to multiply together to give me 21 while adding up to give me negative 10. And those numbers are going to be negative 7 and negative 3. And then I can quickly solve each of these. I'm going to write it for you, but you don't have to write all of this out. So what that means is that x minus 7 equals 0, or x minus 3 equals 0. And so I add 7, and I'll get that x is 7, which means the intercept is 7, 0, not just x equals 7. Or x, so I add 3, x equals positive 3, which is the point 3, 0. So here are my 2 x-intercepts. So now I have 1, 2, 3 points that I can plot on this graph. Well, just to be safe, so I know what my graph looks like, step number 3 is, again, 2 other points. And so, again, my advice is this. Go back to your vertex and say, okay, my x value is a 5. Let's pick stuff that's close to 5. What if we picked, I don't know, 4 and 6, right? 4 is 1 less, 6 is 1 more. So what if x was 4? Well, I'm going to take that 4 and I'm going to put it right here. And so that will give me 4 minus 5, quantity squared, minus 4. Inside here, 4 minus 5 is negative 1. Negative 1 squared is 4. 1 minus 4 is negative 3. And so I have the point 4, negative 3. So there's 1 point. Well, then let's say, well, what if x is 6? Well, that's going to give me 6 minus 5, quantity squared, minus 4. Inside here, 6 minus 5 is just 1. 1 squared is just 1. And 1 minus 4 is negative 3. And so now I have the point 6, negative 3. And so now, altogether, I have the vertex, 2 x-intercepts, and 2 other random points. So I have 1, 2, 3, 4, 5 points that I can use to graph this thing. And so that's exactly what I'm going to do. Okay, 2, 3, 4. I should probably get some graph paper. Okay, so the first thing I'm going to do is I'm going to graph the vertex, which is 5, negative 4. So I start at my origin. I'm going to go right 5 and down 4. So 1, 2, 3, 4, 5. And I'm going to go down 4. So 1, 2, 3, 4. So about right there. And then I'm going to graph my x-intercepts, which is 3, 0. So 3, 0. And 7, 0, 3, 4, 5, 6, 7. Okay, so I have these guys. And then I'm going to graph the point 4, negative 3. So I'm going to go right 4, 1, 2, 3, 4, and down 3. And and then I'm going to graph the point 6, negative 3. So I'm going to start the origin, go, oh goodness, sorry, this is the point I just graphed. This is the point 4, negative 3. I need to graph the last point, which was 6, negative 3. So I'm going to start at the origin, and I'm going to go right 6, 1, 2, 3, 4, 5, 6, and I'm going to go down 3. And here's a trick. I'm not asking you to do this anywhere, but here's a quick trick. It'd be really nice if we had a y-intercept. And so in order for me to do that, what if I let x be 0? Because I'd like to know that. So over here, just for the heck of it, and not because I need you to, but because I want to show you, let's find the y-intercept real quick, which means that x is going to equal 0. So if x is 0, I go and I put my 0 back into this guy. So I'm going to have 0 minus 5 squared minus 4. And so over here, I'm going to get negative 5 squared minus 4. Ooh, this is going to be a really big number. It's going to be 21. Well, darn, that's way too big for me. So somewhere way up here is my y-intercept. I don't know where, but it's way up there. And so what that tells me is that this guy is going to come up like this. Eventually, he's going to get really, really steep, and he's jutting off towards infinity. And that's happening on both sides. And so when it's all said and done, after all of that work, here's my parabola. And now I am completely done. All right, now, number 7. This problem is going to be completely different. So let me write it down real quick, and then I'll tell you what it is that we're going to do. So I have h of x equals x squared plus 6x plus 5. Now, the idea is the same. I still need to find the vertex. I need to find the x-intercepts if I can. I need to find 2 other points, and I need to graph it. However, I can't just look at it anymore and tell you what the vertex is. It's not in vertex form. Well, I need to make it be in vertex form. And so what I'm going to have to do here is I'm going to have to complete the square. Okay, and I need you to bear with me through this first example so that you can see what I mean. All right, so the first thing I'm going to do is, as you know, when we complete the square, we want our x values to be side by side. Well, in this case, they are. I'm going to leave a little bit of a blank space, and I'm going to put my whole number right here. And so what's going to happen is I'm going to draw my scratch work, and I'm going to say, okay, 6 divided by 2 is the number 3. I'm going to put it in parentheses and square, and I'm going to get 9. And so then what I'm going to do is I'm going to say, okay, plus 9. Now here's the thing. Okay, this is what's new as far as us completing the square goes. Once I get this, I'm going to put these 3 pieces in parentheses. Because remember, the whole idea is that this is my perfect square trinomial, which I will factor real quick, real easy. But we know that we're not allowed to actually change the value of the problem. Right now I've changed it by adding a 9 to it. And so since we don't have the other side of the equation, what we're going to have to do is we're going to have to take that into consideration somehow, some different way. So notice that I've put these 3 pieces in parentheses. Well, I've technically added a 9. So I'm going to come over here behind this 5 and I'm going to subtract 9. Because wouldn't you agree that if these 9s weren't there, my problem is exactly the same as what I started with? And so technically this positive 9 and this negative 9 is going to cancel each other out. All right, so what I'm going to do is I'm going to come down here, and I'm going to very quickly factor my perfect square trinomial by cheating and looking at my scratch work and saying, hey, I know that the variable they're giving me is x. This is a positive 3. It's in parentheses and squared. So there's my x. There's my positive 3. There's my parentheses. There's my square. So that's not too bad. The square has been completed, so to speak. And so then I'm going to look over here. These are just whole numbers. What is 5 minus 9? Well, when I take 5 and I subtract 9 from it, it's just going to give me negative 4. And so now I'm going to have this function, h of x equals, and then guess what? This is in vertex form. And so now step 1 is to find the vertex. And so when I look at this thing, it's in vertex form. I don't really care about the rest of this stuff right now. I can say, oh, the vertex is going to be negative 3, negative 4. And so I've taken it, I took the quadratic equation, I put it in vertex form, and now I'm finished with finding the vertex. And so even though it wasn't staring right at me, I was able to make it stare at me. Okay, so we'll come over here, step number 2, and we want to look for the x-intercepts. And so we'll take our function, x squared plus 6x plus 5. We'll set it equal to 0, and now we have to factor. And so we'll have our 2 open sets of parentheses, and we'll stick our x's in there, and we'll say, okay, we need 2 numbers that are going to multiply to give me 5 while adding up to give me 6. Well, that's a positive 5 and a positive 1. And so I'm going to quickly solve this. And so when we look at this, we know that x is going to equal negative 5 here, and we know x is going to equal negative 1 here. But since we're looking for intercepts, we know that this has to be the point negative 5, 0, and the point negative 1, 0. And so now we have 2 x-intercepts. And then, of course, the last thing that we're going to want to do is we want 2 other points so that we have an idea of what our parabola is going to look like. Well, again, my advice was to go back to your vertex and kind of take a look at that and say, hey, I need to pick some numbers that are kind of close to this. Okay, but we can pick kind of whatever we want. So here's a trick for you. If your problem is already written out as a quadratic equation, if you picked x to be 0, these 2 pieces would go away totally, and it would just leave you with the constant, which happens to be your y-intercept. So let's let x equal 0 real quick. Let me write that down and show you what I mean. So if x equals 0, and I'm looking for h of 0, that's going to be 0 squared plus 6 times 0 plus 5. Well, 0 squared is just 0, gone. 6 times 0 is just 0, gone. Leaves me with just the number 5. So I have the point 0.05. There's my y-intercept. That wasn't so bad. And so what if we pick the number, I don't know, let's pick maybe -2, because -2 is pretty darn close to -3. And so let's say if x is equal to -2, well, that's going to be h of -2 is going to equal -2 squared plus 6 times -2 plus 5. Well, -2 squared is positive 4, and 6 times -2 is minus 12. And then, of course, this plus 5 isn't going to change. And so I'm going to get my calculator out because I'm being lazy and it's kind of late. And I'm going to say that it equals a -3. And so what's going to happen is I have the point -2, -3. And so now I have the vertex, and I have 2 x-intercepts, and I have 2 other random points. And I'm going to come over here and I'm going to draw this parabola. I'm going to give it a really good shot anyway. See what this thing could look like. And again, when you're graphing in Hawks, you're going to have actual graphs, so it's not going to look nearly as bad as this. All right, so first things first, let's graph the vertex, which we had said to be -3, -4. So from the origin, I'm going to go left 3, down 4. So 1, 2, 3, and then down 4. 1, 2, 3, 4. So about right here. There's my vertex. Okay, let me graph the intercepts, which are, the x-intercepts, -5, 0, and -1, 0. And so over to the left 1, 2, 3, 4, 5. Okay, got that. And then let's go ahead and graph this y-intercept because that'll help me know kind of what it looks like here. So I start the origin, I go at 5. 1, 2, 3, 4, 5. And then lastly, we have the point -2, -3. So I'm going to go -1, -2, and then down 3. Okay, and so I have these 5 points. And so I know that my parabola is going to look something like this. And so now after all of that work, I found the vertex by completing the square. I found the intercepts by factoring and solving. I found 2 other random points, and I graphed it. And now I am totally done with this problem. All right, we're going to do another one that's similar to the one that we've just done, but there's going to be one major difference. And so we're going to have f of x equals -x squared plus 6x minus 5. Okay, so obviously this is not in vertex form. That's what I need it to be in. However, this is the first one that we have seen with a negative sign out front. And we know that somewhere along the line, our parabola has to open downward since it's a negative. And so what has to happen is, we've learned in the past when we completed the square, that we can't complete the square if this guy is negative out front. I mean, we can, but it's not ideal. So watch very carefully. Here's what we're going to do, okay? Notice that we have these 2 x values. In the past, we separated them, we left a spot, and we put our 5. Well, we're going to kind of do that again. However, I really want this guy to be positive. So watch what I'm about to do. I'm going to pull a negative sign, a -1 if you will. I'm going to pull that out, and I'm going to say, okay, what's -x divided by -x squared divided by -1? Well, it's positive x squared. What is positive 6 divided by -1? Well, it's -6x. And so then I'm going to leave a blank spot. I'm going to close my parenthesis, and I'm not going to touch this -5. He's going to stay exactly the same. And so now what I'm going to do is I'm going to pretend like all I see is this stuff in the middle. I'm going to say, hey, this is all I have. I'm going to go ahead and complete the square just like I typically would. And so I'm going to draw my scratch work, and I'm going to say, hey, look, this is a -6. And so I write -6, and I divide it by 2, which of course gives me the -3. And when I square it, I get a positive 9. And so in my blank spot goes my positive 9. Now, in the last problem, we added something over here, so we had to subtract it. Now, this is where it gets a little hairy, okay? So watch very closely. Okay, if you're following along, just watch. If I take a -1 and I multiply it by this x squared, that's where I got my -x squared from, so that's good. If I take this -1 and I multiply it by this -6x, it's actually a plus 6x. This little guy doesn't matter because he's not included. So really, if I were to take this -1 and multiply it by this number 9, technically speaking, that's actually a -9. And so when I'm looking at values, I actually took the number -9 and I put it into my problem. Well, I've put the -9 right here. And what's the opposite of a -9? Well, that's going to be a +9. And so even though it looks like I've written a +9 here, what I've really written is a -9 because -1 times the 9 is really a -9. And so in order for me to balance that out, I actually have to add a +9 over here. Now, this piece is going to be my perfect square trinomial. And so I'm going to come down and I'm going to say, okay, my negative sign has to be there. I don't need the 1 anymore. Okay, I really didn't need it to begin with. I just wanted to show you. This is my perfect square trinomial that I'm going to factor real quick by cheating and looking over here in my scratch box. I'm going to say, okay, they give me an x. This is a negative 3. It's in parentheses and squared. Here's my x. Here's my negative 3. It's in parentheses and squared. And then I'm going to look over here and say, hey, look, these are just numbers. And negative 5 plus 9, that's just going to be a positive 4. And so just like that, I have this guy right here. This is my vertex form. And so the idea was exactly the same. I just had to do one extra step. I had to say, you know what? I really need this leading x squared to be positive. And so I made it positive. And so step number 1, really in Hawks, wants me to find the vertex. And so from just looking at this, I know that my vertex is going to be 3, 4. And then it's going to say, okay, well, step 2, let's find some x-intercepts. And so what I'm going to do is I'm going to go back to my initial problem, which is this, negative x squared plus 6x minus 5. I'm going to set it equal to 0. But I know that I'd like to factor for this thing to be positive. So I'm going to divide everything by negative 1. And so I'm going to get x squared minus 6x plus 5 equals still 0. And so now I can factor. And I'm going to say, okay, two numbers that multiply together to give me 5 while adding up to give me a negative 6. And in this case, the numbers are going to be negative 5 and negative 1. And I'm going to solve very quickly and say, oh, x must be positive 5, x must be positive 1, which tells me that one x-intercept is 5, 0, and one x-intercept is 1, 0. And so now I have my two x-intercepts. And then, of course, step number 3 is going to be 2 other points so that I kind of know what this thing looks like. And so again, I'm going to go back to my vertex, which I lost it, which is 3, 4. And I want to pick numbers that are close to 3, but I cannot pick 5 or I cannot pick 1 because they've already been used. So what if I just say, oh, I don't know, let's pick 0. And we want to pick 0 because we can cheat. And we can look back up here and we say, hey, look, if we put x in 0 as to be 0, guess what's going to happen? I'm only left with this constant. And so without any work, I know that if I choose 0, then y is going to equal negative 5. And that's my y-intercept. So 0, negative 5. Bam, no work. I have 1 point. Well, now we have to pick an actual point and do some work. Excuse me, so I don't know, let's pick 2, because 2 is close to 3. So what if x is 2? Well, that's going to give me the opposite of 2 squared plus 6 times 2 minus 5. Now this is where I know you guys struggle sometimes, so do this first. Say 2 squared is 4, and the opposite of positive 4 is negative 4. And then 6 times 2 is positive 12 minus 5. And so negative 4 plus 12 minus 5 is going to leave me with the number positive 3. And so if x is 2, then I know y is 3. And so the point is 2, 3. And so now, again, I have the vertex. I have two x-intercepts. I have the y-intercept, and I have some other point. And so now I'm ready to graph this thing. And so I come down here. Let's see. Okay. Got my graph already here, and so I'm going to graph my my vertex, which is 3, 4. So I start at my origin. I go to the right 3, 1, 2, 3, and I go up 4, 1, 2, 3, 4. So right here, and so then I will graph my intercepts, which are 1, 0 and 5, 0. 1, 2, 3, 4, 5. Okay, and then I will graph my intercept, my y-intercept, which is 0, negative 5. So I start at the origin. I go down 5, 1, 2, 3, 4, 5. And then I'm going to graph the point 2, 3. So I start the origin, I go over to the right 2, and then I go up 3. And so now I already said that my parabola had to be opening downward. And you can see that that is actually what's happening. And so I will draw my points. I will connect my points. And now I am totally and completely done. Okay, I'm going to do one more, but I'm not going to do it all the way. I just want to show you something so you don't freak out when you see it. And so here's the problem. H of x equals x squared plus 3x plus 2. Okay, so now what's going to have to happen here is, again, this is not in vertex form, but I want it in vertex form. So I'm going to have to complete the square. But when I draw my scratch work and I take my b value, which is 3, and I divide it, this is not a nice, neat whole number. Well, we've talked about this. We said when this happens, to please just go ahead and leave it as 3 halves. And even though it looks weird, excuse me, go ahead and put in parentheses and square it. Now, you're probably reaching for your calculator, but don't. We know that when we're squaring a fraction, we square the top, and then we square the bottom. And so 3 squared is 9, and 2 squared is just 4. And so I didn't even need my calculator for that. And so what I'm going to do is I'm going to say, okay, x squared plus 3x. I'm going to leave a little bit of space. My plus 2 is just hanging out. And since this is a nice, neat positive 9/4, I'm going to come over here to my problem, and I'm going to put plus 9/4. And since this isn't one of those weird ones where it's negative out front, since I added 9/4 here, I'm going to have to subtract 9/4 here. And so now this is my perfect square trinomial, which I get to factor real quick by looking over here and saying, hey, the variable they give me is x. This is a nice, neat 3/2. It's positive. It's in parentheses and it's squared. So here's a nice, neat 3/2. It's in parentheses and it's squared. These are just whole numbers. Well, they're not whole numbers, but they're just regular numbers, rather. And so we're going to calculate this, and I'm going to show you again how to type this in just to make sure you can. So you're going to put the number 2. You're going to put a subtraction sign, parenthesis, 9 divided by 4, enter. Now remember, we don't want decimals, and so everyone's calculator is different, but somewhere you have a button that's going to allow you to take this decimal and turn it into a fraction. Most of your calculators, it's the FD button, okay, so you might have to look for it. But I'm going to get negative 1/4, and so this is just going to say subtract 1/4. And so I get to write that h of x equals x plus 3/2 quantity squared minus 1/4. And so step number 1 in Hawks is going to say, hey, find the vertex. Well, now it's in vertex form. I don't care about any of this stuff up here. I only care about what I have in front of me. And so from looking at this, I know my vertex is going to be negative 3/2, negative 1/4. And now again, in Hawks, it's going to ask you to go on to find the x-intercepts and to find 2 other points, which I think by now you can. But I wanted to show you what happens when you have to complete the square, when you have to use a fraction, because I know that we joke about it a lot, but I know that fractions are not our favorite F word, and so I want to make sure that you guys have a refresher on how to do this. Okay, so that's it as far as these homework problem goes. Thank you, and I hope this helped you out a lot.